Cheating is always something you're going to have to look out for when creating a game. You need to play your game over and over and over again and check to see if there's anything that your players may do to get around the intended way to play the game. And one of the most overlooked ways of cheating that game developers forget to add in is looking through walls. The player can just sidestep in room space in the real world, and inside of the game, the character will just slip through the wall. So, how do you go about preventing that? That's what we're going to talk about in today's video. I want to make you aware that you can download the project that we're about to make on my Patreon. So if you're interested in just grabbing a copy of the Unity project or a Unity package containing all the code and everything, it is available for you to download there. So there's a link down in the description. Check that out if you're interested. And another thing before we get started is I need to thank Coricia for providing the demo of this project for me to be able to go through and show the rest of you. So make sure to thank her on our Discord. Now, first things first, as usual, we're going to set up a super basic Unity project using 3D URP in Unity. And I'll, like we always do, start from the very beginning, show you how to set it up in the current version of Unity. And there's time steps below if you want to skip ahead. So first things first, we want to go to Project Settings, scroll all the way down to XR Plugin Manager, and install the XR Plugin Management. Project Settings can also be found in Window Project Settings if you don't have it pinned like I do. Next, we're going to check OpenXR. That's going to download all the SDKs and information we need to communicate with an XR device. And it's also going to swap our input mode over to the new input system, which will end up restarting Unity after the pop-up happens and we click on yes. There we go. It's gonna prompt you to restart your Unity project. Just hit yes. All right, so OpenXR is now downloaded and we'll get a little warning arrow, and that's basically telling us to swap on over here to OpenXR and add in some interaction profiles. So we are going to use Oculus Touch for this particular demo. If you want to add other things or building to other devices, you'd add those here. And then we're only setting this one up for PC. If you want to know how to set up for Android and build, I have a whole video about that, so check that one out. I'll link it up in the top corner. And then for this particular project, we're going to be using the XR Interaction Toolkit provided by Unity. And we're going to hit the plus sign, add package from git URL, and type in com.unity.xr.interaction.toolkit. Hit enter, and that will go and find the toolkit and download it. And the toolkit is in a 2.0 version, so it's just going to prompt and say, hey, if you have the 1.0 version, it's going to break some stuff. But since we are in a new project, we're just going to hit OK. Now here at the bottom, you should see the XR Interaction Toolkit show up, and if we scroll down and open up the samples, you'll see that there are some starter assets we can download. So I'm just going to import that, and that'll give us a folder down here in the project view. Let's double click into that folder, and then we're going to get a bunch of presets here. So I'm just going to go through, and up in the inspector panel, you can add each one of these presets. I'm going to go through and click all 5, add each one. And these just preset up some interactions and button presses and whatnot. Back into project settings, we go into preset manager, and then these are all the presets that we just added. And in the action-based controller, we just need to specify the filter between left and right. So inside of the filter section, let's type in right and left. There we go. Now back in scene, over in the hierarchy, we can right click. We should have an XR option, and then we have a bunch of XR things we can add. If you only see one here, then you need to go back and make sure you downloaded everything correctly. We are looking for the XR origin action based, click on that, and it should add in your XR Origin and the XR Interaction Manager. On the XR Interaction Manager, we're going to add a component, and we're going to add the Input Action Manager. And underneath the action assets, we're going to add in one asset, and that asset is going to be the default input actions that we downloaded from the starter assets. Did you get all that? All right, so now we have a very basic XR system that if you hit play now, should go to your headset as long as if you're using an Oculus, your headset's in link mode. If you're using a regular headset, as long as it's connected, you should be able to move around and see some lasers flailing about. While we're here, let's add in just a really basic environment. So I'm going to create an empty game object called environment. And inside of here, let's add in a 3D object plane. And let's add a couple walls too. So there we go. Super basic scene setup. We've got a wall, we've got a ground, and then a couple of cubes to navigate around. And you'll notice that each of these have a box collider attached to them. That's what you're going to need in order to have collisions be calculated. Now, we can't move yet. So there's one more thing we need to add as far as XR for movement. So we're going to right click in our hierarchy again, go to XR, and we're going to add a locomotion system action based. And action based just means we're using the new input system. So in the action based system, we are automatically given a teleportation provider and a snap turn provider, but I'm going to turn both of these off by unchecking them, and we're going to add continuous move, make sure this is action based, and continuous turn, also action based. And as long as the left and right hand turn actions have something pre-populated, that means that you set your presets up good. And then we want to move with our left hand. That's normally standard. So in the continuous move provider, we're going to uncheck the right hand movement action. We only want to move with our left hand thumbstick. And then with our right hand, opposite thing, we want to be able to turn with our right hand thumbstick. So just unchecking and checking the appropriate controller. The locomotion system, all of this will get automatically populated. If you wanted to, you could say your forward source is going to be your camera. If you want your forward source to be whatever controller you're using, this is where you would set that up. And then, whenever you're doing gravity or whatever. And we're going to up the move speed to something like 3, because I always find 1 is very slow. All right. So we have basic movement. So let's jump in, and I'll show you that. All right, so let's jump in and just look at basic movement. What does that give us? All right, so I load into a scene. You can see my controllers there. I'm gonna scale the gizmos down a tad. There we go. All right, so you can see the camera, which is my head, moving around. And you'll see that I can just walk straight through this wall. Walk straight through the wall. I can walk straight through these cubes here, walk right through everything. Nothing is preventing me from moving. I can crouch up and down and whatnot. So how do we fix this? Well, one way to do it would be to add a character controller. So on our XR Origin, we can add a component character controller. And you'll see it adds in a capsule over our character. And we can kind of bring in the radius. Most people are around 0.25 is a good kind of body radius. And then for the height, we're going to just adjust this up 1. And you'll see over here now it is at a good height right on the floor. So if we hit play from here, let's see what happens. You'll see when I move around, the character controller follows, and it prevents me from moving through the wall and everything here. But the problem with this is, watch. I can just step right out of the character controller. See the camera moving around? I can just look right through the wall. And I can also crouch down. and the character controller doesn't follow us around. And that's good for if you're moving around with a joystick, but if you're set up in room space and the player can just still physically walk around, that's not ideal. So there is a fix for this. And the fix is going to be a very simple script. So inside of our assets folder, we're going to right click, create a folder there, scripts is what we're going to call it. And then inside of the scripts folder, we're going to right click, create C# script. And we'll call this room scale fix. And this will just, prevent our player from going through walls and whatnot in room scale. So first things first, let's add our room scale fix script to our XR origin. Just in the parent game object is fine. And then we're going to double click it to open it up in our editor. Before we get into the coding, if you have not watched one of my videos, I am using JetBrains Writer as a IDE, and so some of the colors may be a little bit different than yours. You may see some things like event function and some other integrations I have may be a little different than yours, but the code and everything should be exactly the same. Little disclaimer there. So first off, so you'll see these are grayed out. That means writers identified this script is not using them, so I'm just going to delete them and then clean up our script a little bit. So now we just have a start function, and let's go from here. So the idea behind this script is every frame, or every fixed update rather, so every physics update that happens, we want to move the character controller capsule to exactly where the player is standing in room space. So we're doing that every physics frame, and in order to do that, we need access to the character controller, and we need access to the XR rig so we can get some properties off of that. So let's do that first. Let's make some global variables. Make a private character controller, and we'll call this character, and a private XR origin, and we'll call this XR origin. And you'll see Writer automatically deletes the private, because if you don't type in private, then C# automatically assumes that your variable is private. So those are the kinds of things I'm talking about. Writer makes a little bit of difference. It's well worth it if you're interested in it. Not sponsored. All right, and then in our start function, we want to get access to this character. So we're going to say get component character controller, and then same thing for the XR origin, get component XR origin. And since we're getting both of these from the start method, we want to make sure, so up above the class, we're going to require both of these. So require component type of character controller, and require component type of XR origin. There we go. So basically, whenever we add this script to something, we just want to make sure both of these components are there, because we're going to be using it later. And if they're not there, it'll break our code and whatnot. So adding in these little checks is useful. And you'll also notice that when I added in the get component XR origin, we added this using statement up at the top, unity.xr.coreutils. That gives us access to the XR origin and all of those properties. So now in the fixed update, we want to fixed update. There we go. So now in the fixed update, we want to adjust the capsule to the center of wherever the character is. And we can do that by just getting the position of where the headset is. So first we need to figure out where the camera is. So where the headset is also where the camera is going to be. So we're going to go off the camera. So we'll create a new variable called center point, and we're going to have that equal to the transform.camera dot inverse transform point. So what this does is transforms the position from world space to local space. So we're basically taking wherever the camera is in world space, converting that over into a local space. So inverse transform point. And we're going to grab the XR origin dot camera dot transform dot position. So what this line does is grabs the camera, whatever camera the XR origin is using, the transform position of that, and then converts it from world space to local space. And then we're going to set the character center point. So this will be the center point of the character controller now, to a new vector 3. And the x position is just going to be the center point dot x. Half of the character height is how far up we need to go. Center point's here. Y position is going to be half of the character height. So we're going to do the character dot height divided by 2. And then we're also going to add the skin width. So there is a width of skin technically around the character controller. So we'll do character plus skin width. You want to get very precise with it. And then finally the center point dot y, or the dot z. And let me clean this up a little bit. All right, so we're getting the local position of the camera, and then we're setting the center point of the character controller, that capsule, to whatever the X point of the camera is, whatever the Z point of the camera is, and then half of the capsule's height, because we don't need to really adjust that too much at the current moment. So let's save that and go back to Unity and see what happens. You'll see when I move my head back and forth, like just even a slight movement, you'll see the character controller actually moves with me now. And I can move around with my joystick still. And I don't really go through walls. And then I can very slightly push through the walls. So you'll notice there's still a little bit of like movement I can do when I push through walls. So if I go really slight, I'm still moving through the walls, but it's much better because it follows my actual character in world space as opposed to just, you know, the center of wherever the XR origin is. So there's two things we need to address at this point. One, I still can't get under the little crouch spot that we made. So we want to have the character controller scale up and down based on if I'm actually physically crouching in the real world. And then we also want to address the ability for me to still be able to creep through walls. Like it's a little tougher now, but I can still look through the wall if I really wanted to. So let's address that as well. So back into code. Let's fix the height first. So the height is going to be our character dot height is going to be equal to whatever the XR origin dot camera in space height. So this takes into account your VR headset's height off of the floor. So wherever you set your floor, this is that height that we are collecting. And then we're also going to add about 0.15 of a meter. And that is about more or less the distance between your eyes to the top of your head. And I'm getting this in reference to Valum actually did a video about this too. So I'll reference that down in the description as well. So this should allow for crouching. So we are automatically adjusting the height. And then the reason that we're using half the height in our position is because if we crouch down, we want that little height marker in the middle to get shorter and shorter and shorter, and taller and taller and taller as the the center point moves up and down, more or less, if that makes sense. That'll fix our height. This is still fixing our position, and we want to fix moving through the walls still, and that is there's a there's a trick. And the trick, I need to give credit to Mordak, Moardak, from the Discord. This person was able to discover that if you just kind of bounce the capsule around just a very tiny amount, not perceptible by the user, but if you like are moving it every frame just a little bit, then it will recalculate the physics and not let you actually push through walls. So the way you would do that is we just say character.move, and we're going to do a new vector 3, and we're just going to move it ever so slightly in every direction. So we're just going to do 0, 0, 1 float, and then the y direction will go negative 0, 0, 0.001. So this will move us down so we're touching the floor, and then 001f in the z direction. And then we want to move it right back. So we're moving in one direction, and then we're moving it immediately back to the same position. So the player won't perceive that they've moved, but Unity's code will, and every time the character controller moves, Unity automatically will update the physics and see if the character is actually allowed to move there. So we will update that, and then this should allow for, you know, the collision with the walls and stuff. And then actually we're moving down both times. So just so you can get that firm hit with the ground there. Let's save that. We've got height, we've got position, and we've got collision all in here now. So back in Unity, let's see if this works. All right, so you can see I'm moving around. As I move around, everything seems fine in the normal world, but if I move up to a wall, I can't push past it with my thumbstick, and it won't let me push past physically either. And then also you'll notice that I can crouch. So if I crouch down here, it lets me go through the little gap we made. So now we have an anti-cheat way of moving around so your players aren't seeing what's in the next room before they should. Let me know if this was helpful for you. And if you're interested in getting a full course for learning how to do VR, lots of tips and tricks like this, from learning C# to learning Unity to learning more advanced coding, there is a link down in the description for when I release the course that you can be on the newsletter and get a very deep discount and be the first to know. I'm going to do a limited run there at the beginning. So if you're on the newsletter, you'll get first access to the VR course that I'm going to release here in the next few months. So make sure to sign up for that down below. If you'd like to download the project, there is a Patreon link also down below. And I look forward to seeing you in the next video.